Okay, from the name itself, you should understand the meaning of intrinsic semiconductor is, the meaning of intrinsic semiconductor is intrinsic semiconductor. Okay, yes. Intrinsic semiconductor means pure semiconductor. Here there will be no doping of electron. Doping means adding impurities. We will not add any impurity in the case of intrinsic semiconductor. Okay, now what in the case of intrinsic semiconductor? In the case of intrinsic semiconductor, we can take carbon, silicon, germanium. Okay, but silicon and germanium are mostly used, so we can consider silicon plate. Okay, see what are the properties of this carbon, silicon, germanium. See, in this they are tetravalent. Tetravalent means in the last shell there will be only 3 electrons. If we can consider, why we are considering, see, silicon and germanium. If we are considering, so in the case of silicon and germanium, there will be tetravalent impurity. Okay, there will be tetravalent impurity. Now let us consider that we are having a silicon. See, I'm drawing this diagram here. I'll just draw this diagram. Okay, we have silicon, we have a silicon structure. Tetravalent impurity means on the last shell there will be tetravalent means in the last shell there will be 4 electron, not 3, 4. Okay, we are considering silicon, 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 sorry, silicon, 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 and silicon. Okay, now if you're considering like this something, okay, in between the semiconductor, they are connected with the help of covalent bond. See the covalent bond. Okay, now we have tetravalent means okay, there will be 4 electron. So there will be 4 electron on the, see, for this silicon, if I am drawing for this silicon, I'll be having 4 electrons here. For this silicon, this is 1, 2, 3, 4. Or you can say, or if I make it more precisely, I can say this is the first one, second one, third one, and fourth one. And rest more 4, it will be borrowed from the neighboring elements. 1, 2, 3, 4. And their octet had been completed. Now, if you are increasing the temperature, there will be the breakage of the bond, and because of the breakage of the bond, this electron will break and it will start to flow. But the breakage, it will be so small, the breakage will be so small that the current which we will be getting will be very low. And because of that, it will be of no use for us. Okay, so this is why what we are doing, we are adding in some impurities. Why tetravalent is not preferable? Because if it shares, or if it gain electron, and after breakage the amount of electron which we are getting are not enough to overcome the requirement of fulfilling the current. Okay, now let's see.